Hey everyone, so today we'll be solving a Leetcode contest for a fall, and yeah, let's solve it. I wasn't able to give this contest, so I'm just going to try to solve it now. So let's just solve it one by one. I think that's where I open up our first problem, and we're going to solve it with formula. We're given a string s consisting of a lowercase English letter, a prefix of s is called a residue if the number of distinct characters in the prefix is equal to length of prefix mod 3. With the count of residue prefixes in s. All right, cool. So is equal to when of prefix minus prefix. Well, that's not very hard for us. All right, so we're just going to use as a prep class. This is called ST, and then we're just going to basically what we're going to do. We're going to have an answer, and then we're just going to go for every single letter in S, and then we're just going to do st dot cancel that, and we're just going to go if I plus one modulo the calculus of modulo 3 or equals st dot size, and we do an answer plus plus, and we're going to use programming and so on. Uh, let's see if it works. 2, 1, 2, 1, 2. I think it should work now. Let's move on to the next problem. Number of centers of arrays. You're given an integer uh, subarray is called center if the sum of elements is equal to sum of all if sum of its elements is equal to the last is equal to at least one element within that same subarray. Okay. So all single elements are centered with a centered array. Okay. So basically a centered subarray is a subarray that whose sum the entire sum of the subarray is equals to at least one element. Got it. All right. Yeah, feel like that's how it is. Um, okay. Mhm. Uh, what do I do? So its sum is equals to at least one element. Alright. So that can only happen. Alright. Mm-hmm. Got it. What are the restrictions here? Well, this is a small array, so we can probably just mm-hmm. We can probably just just brute force it. I don't want to think about. So we can just read the entire array. We can maintain a summary about and once we did that array, we can just add a sum to it. And we can just see that um basically if we have found the element till now. So how do we do that? Basically what we can do is probably just stab along something like I don't know, something sort of P or something. So that's true, right? We can just have a boolean here, and we can just do it if you have some, then we're just going to leave that answer. And then we can just return the answer to us. So we have a 5 here, and we have 2 here. Well, okay, structure. Why did it chuck? Um, so these are good ones, and then we have another one here. Okay, oh, that's why, oh my god. That's all I have to do. What the hell? Hmm. Just have to go through the entire cycle, right? We have a starting point and we have an ending point. Well, what? So, what is that? I don't really know what this is. Oh, it's already there. Wait, why is it there? We have to go to the older horizon, guys. We have a new song. We have J that is going like that. Sum plus equals number of J, I should be. Oh my god. And this should be like that only. Should work. You're given an array of words or n strings. Each string has a length n and contains only English letters. Okay. Two strings S and T are similar if we can apply the following operation any number of times so that S and T becomes equal. Uh, Replace every letter in the chosen string with the next alphabet. Okay. And the number of pairs and it's just that. Alright. This is not that hard. Um, yeah, yeah. So we can have an answer equal to zero, and then we can have a vector of string PNP or something. So we can, the function here. So string from variables, where we can just have our string result equal to zero. So what it is going to be, yeah. We're going to go the CNS, the C let's go equals A, minus let's go equals that C minus A plus 1 plus A or something. Yeah, basically C plus 1, yeah. And then we can just return the results. And then we're just going to maintain our pairs. We're going to have the X and words. We'll do that. We can just go back. Our fun class. And then what we're going to do is basically, um, since we're starting for every single letter, we can just, instead, we don't even need this. We can just have a map of string, comma, count, link or something. And then we can just go with every single string of words and just do, NPM export plus. And then we just go to search for that. So, we're just going to go and the words. We're just going to calculate the string with PMP as convex, and then we just got to our answer and the penalty. Uh, we'll find the number of pairs of indices is it were yeah, you can apply the operation diffusion 6 times. Yeah, all right. Cool. So okay. So we can make fusion go to layout. Yeah. So we know that mhm, yeah. So the thing is that the difference for all the characters would be same. So technically, instead of taking everything to a particular point, we can just basically just do something that takes them to that value. Uh-huh. I believe for each and every character we have to do this 26 times until we are able to come to the same character. So, yeah, uh, at some point this is happening my job, it's going to come to its original way. I don't know this is something rather just have an answer. Existed A B C D E F G H I J K L M N O P Q R S T U W X Y Z. Yeah, I mean technically it should be like that. It should okay, it should be a temporary here. Yeah, one and hmm, interesting. So we can take this to this one, and then we can take AA to AA. So all right, we can also have here next to it. Mm-hmm. Basically, just yeah. So this doesn't consider that. So we can just maybe I don't know, fucking yeah. I mean, I fuck that. I don't know. How many pairs are we going to have? For two, we have two times one by two. Yeah. So we can just probably just go through. Um, excellent. So all right, we can have a one around pause. Mm-hmm. What the hell? Are you kidding me? What? Why? Why? What? What the hell? Oh, we can just do this in that hand, not to blow up our limits. Mhm. Plus value, let's just call it the value only. Um, the value is zero. This one should work now. It's like 26 times 25, so it should work. Yeah, it's for maximize bitwise and after increment operations. So we are given an integer array nums and two integers k and m. You may perform at most k operations. Okay. In one operation, you may choose an index I and increase number of I by 1. Return an integer denoting the maximum possible bitwise and of any subset of size m after performing k operations optimally. Alright, so we can increase them, and then we have to select the subset of size m. Alright, okay. If we sort them, basically the best answer that we could get is by making everything equal to the maximum value. Yeah. So we will only consider the um we will only consider sections of m size in assorted nums. So for example, 1, 2, 3, we'll consider 1 and 2, the maximum value that we can go in that. Then 2, 3 for that, we'll consider for that. So what is the maximum that we can reach? So for example, if we have a 1, 2, and a 3, then the maximum value that we can achieve for this probably is uh we are going to have 1 and 2, and k I think was a, and then we're gonna have a 2 and 3, and k again a. So what we can do here, basically, we have to distribute it such that, so if we add a 4 and a 4, that won't be equal, so we have to go with a 4 and a 3. If we do that, we'll have a 5 and a 5. 5 and 5 is equals to 5. Similarly, we'll just have to add again a 4 and a 3. So that will give us 6 and 6, so on to 6. So that's how I think we should move in a sort array. And how do we find that out? So let's just say we have 2, 4, something like 7 and 11, and k was, let's just say, 10. So first of all, we're going to try to make everything equals to 11. So kind of like um, everything equals 11. So it would be a plus 4, a plus 7, plus 9. So that's not possible with the current value. So now this is a problem. Let's just say we do have those values. So let's just say our quota is, uh, let's just say that our quota is rather, uh, so k is basically greater than this, then we cannot make all these values equal to that. But then, like, you know, um, so basically, how do we make this equal to that? So how do we know that we need it? So it's nothing but the sum, which is 18, 22, 24, and we have to subtract that from 44. So we need 20, as we can see here. But thing is that we are not able to do it. So this is a very good example. 2, 4, 7, and 11. K equals 10. And M is 4. As you say, this is some kind of summary that we have selected. So how do we make this? So we know that 11 is nothing but 1 and 0, 1, 1, right? So now we'll try to make everything equals to at least 8 so that we can have the and equals to the 8 value. So we'll just go for this and probably see if we can do that. So, or rather, let's just start by taking out bits and something. So, we can have a lot of values in here, like everything can exist or cannot exist. Um, so technically, I think it depends on how big the numbers are. Numbers are pretty big. So we'll try to make everything equals to 8. So we had a plus 1 here, we had a plus 4, and we had a plus 6. As we can see that this is also exceeding this, so we cannot do that. So we just take this bit out, and then we probably try to make everything equals to at least 3 now. So we had a plus 4 here, and in order for 4 to have these two bits set, we have to make 4 equals to 7 now. So we add a plus 3 to it, and then 7 is already fine. So we added nothing. So now we'll have the and value as 3. But if k was 11, then we could have made everything equals to a, and then we could probably have the and equals a. So this is how we can do this problem. Now this is dependent on like how do we move these values around. So that's an interesting thing we can do here. Not sure how we can do this now because let's just consider 1284k7 and 1284k equals 7 m equals 3. So we can convert this to 1248 and then k is 7 and m is 3. So we have two arrays arising from it. We have 1, 2, and 4, and then we have 2, 4, and 8, and our k is 7. So we try to make everything equals to 4 first. So we plus 2 and plus 3. So that is well under that. So we can make all these values equal to 4. Now let's try a 5. So we need a plus, since everything is 4 already, so we need a plus 3 now. So yeah, we will do a plus 4, plus 3, and plus 1. Uh, or rather, yeah. So, um, yeah, that's interesting. So, in order to make everything equals to 5, we probably have to do this. Like we have already exhausted 5L, and then we only have 2 left, so it cannot be done. So the answer for this is probably 4. Now for this, we can try to make these 4. So it will be a plus 6 and plus 4, so that cannot be done. So rather, we'll just, what we have now. We have 100, and we have 0100, and then we have 010010. So the most you can do is try to make this not 1. So we'll do a plus 1. We'll do a plus 1 and we'll do a plus 1 here. So that would make these values is that. And we can also try for a 2 now because that can be done. So we can try for a 2. But rather we won't be able to do much here. So I believe the answer would be 4. There's a lot of variables in this problem. I believe so. Yeah, not sure what can be done here. Um, it's a good problem though. Hmm, that's interesting. We're probably going to interesting. How can I think about it now? Let me take a shit and I'll be back. Oh shit. You know, this stream was this drama is honestly the fucking worst though. Like, okay, if you're able to make that, that's fine. But then it's become so fucking weird, you know? Maybe we can buy a research on the answer. Yeah, probably. So what's the tendency that it's something going wrong? And this is well after trying to lower number, but then it becomes kind of weird, honestly. Because, hmm, how do I make that equal to that? Basically, I just have to go bit by bit. I think maybe I can try a binary search maybe once, you know, just for the sake of it. So let's just try it once. So we're going to go in sections. So yeah, yeah. Then we're gonna go for sequence maximum answer contract. I two average n minus one power. And we're gonna have some answer. School at zero. And then I'll return the answer. So what does our check do? A check is basically a dumbass function. Just takes uh no, probably, and it checks what it has to do. So basically we're gonna have a minus one, we're gonna have a let's call it like a big value. Let's call it like 29 or something. While house greater than all plus one, 2, 1, 4, 5, 5, minus. We'll divide by 2. I will just do if root of m, then we have to increase it or we're in this reform yeah. So how it does our with well we also need the information um we have another value return boolean. I like check that returns an integer value. It's a probably fucking weird because why are you removing an integer value back? But that's what we need for our problem. So we're just going to go through the entire array and then try to see if we can make the value. So what do we need for that? Basically, we're gonna go bit by bit. So let's just put it like I equals 31 or something, and we're gonna go with every single bit in a value. Um, if the bit is set for the value, so we'll just do a value now one. Then we're probably going to just going to go through the entire array and then try to we just try to have some operations here. So let's just call these ops as since this ops can be very big, so let's just call them zero. And in the end, you just have to return ops doesn't equals k or something. So now, since this bit is set, we have to go for every single value and probably L to R. And we just have to say that that bit is not set, then we have to obviously add some numbers to it to have that bit set. So how many numbers do we need? So for example, if we have 13 and we want to set the basically this is how 13 looks probably. I don't fucking know. It probably looks like this. So if we want to set these bit, how many values we need? Or rather, let's just say that we have this number. We're gonna set this bit. So how much effort will be needed to set this? Well, we want to go from 8 to 12. So that's like 4 plus 4 or something. Well, let's just say that now we want to set this. So how much effort is it going to be needed? Yeah. Well, we are already at 10 now, so we just need to uh, probably if we increase the values, and also the thing is that yeah, all right, question and you're delusional, boy, you're wasting your time. Why are you so obsessed with me, boy? I wanna know. Lying that you're sexting me while everybody knows. See right through your with your Napoleon complex, man on the earth still couldn't get this. Oh well. We're gonna set this how much I need, bro. What the hell? This is 16. This is 8, this is 4, this is so we have 18 and we wanna go to probably 16 plus 8 or something. 24. And you know, 6. How the fuck do you do the minus to 6? It's basically whatever the value is here. I'm just trying to tell you I feel too much money turned out a deal. And whatever you said here. Too much money turned out a deal. Oh, just that type of I do niggas know. When the real stay on, let the fake it go. Let the fake go home. Man, this problem is X. I don't know what to do now. We got something chilling going on, yeah. My dinner's ready almost. I don't want to finish my dinner because of this shit. Fuck this problem. What do I do here now? Dun, 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 dun. तेरे माथे के कुमकुम को मैं तिलक लगा के झूमूंगा तेरी बाली की चुन चुन को मैं दिल से लगा के झूमूंगा मेरी छोटी सी भूलों को तू नदिया में बहा देना तेरे झूले. One thing we can, oh my god, one thing we can do is probably is use a good old, good old, good old way to answer this problem. Da 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 da. Maybe just, I don't know. Yeah, I've thought about this problem for like 20 minutes now. Now, I mean, this is something we can continue, but I don't want to implement this, so we're just going to consult our good old, good old, good old, good old, good old, good old boy. Um, da, 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 da. ChatGPT.com. Yeah, maybe later. How do I solve this? I mean, I already have the answer for this. I think I already thought more about it and going in the right direction. Tell me what I need to take now. Hmm. Yeah, we know, dumbass. No, but we don't. understand to make some stuff to make a subset equal to some pattern, it's always a good idea to um, have elements that are parallel in each other. Yeah, it can get where it can go wrong. Yeah. So what direction should I be thinking now? Um, Please be elaborate. I don't need jargons, symbols, emojis, whatever. Just plain text or something. Plain text. Quality over quantity, please. And tell you what I do. Stop thinking about choosing the subset first. This is the main mental shift you need to make. Right now, your mind is doing this. Which elements should I pick? And how do I make them equalish? Yeah, that's what I'm doing. Yeah. That feels natural, but it puts you in a combinatorial corner. Instead, you need to think about this. What value do I need? What value do I want the and to be? And can I force m elements to reach these values? Subset is a consequence, not a decision. You know, explicitly choose a subset first. Okay. Understand what an and result really demands. If the final and is some number x, that means that every chosen element after increments must be at least x and contain all the bits of x. Okay. Nothing else matters. They do not need to be equal to each other. They do not need to be close to each other. You only need to satisfy with good balance. Yeah, that's like the basic thing, really. This is not helpful, but however, this is like the person's value. Okay, cool, bro. I'm wrong, bro. Wonderful. It's a target value announcement. For a moment, imagine someone hands you a candidate value. Yeah, so my binary search is fine, I guess. You know, see, real cost per elements for each number, how many plus one operations do I need to make? This is easy. Some elements are variable costs, some can be fixed. Big the smallest costs, which is some is maintained. So, fixing the item value, I think binary search and answer is a good way. And finding the operations required could be basically done by like summing the elements and basically doing uh, x times n minus the sum. It's a very important moment because what you just said reveals exactly the last important assumptions that the universe. You're told the whole puzzle where you're provided for. Oh my god. Binary search on the analyzer is not valid. Binary search only works when the predicate is monotone. The lie is exposable. One more depends on the results and not the sounds. Wow. I will construct the n value bit by bit from highest to lowest for each 10 added unmask. Uh, I'm gonna do a more like thinking about can we have just paragraphs only valid of the having valid in dollars seconds. What the fuck is that? Yes, I'll be ugly now. Let's just start thinking about making numbers equal or raising them Well, this problem is not about equality, it's about forcing some inputs to be present. Think of the answer as a set of bits, not as a number. The numeric value comes later. What matters is which bits are what. Ask yourself this single question again and again. If I demand this bit to be one and the final and can I still afford it? That is the kernel. You don't decide the subset first, you decide the required bits first. Okay. For any fixed set of required bits. Some numbers are already valid, all that once you know them. If it's affordable, keep it. Hmm. So when you say start from the highest bit, do I consider the highest bit 29 and then see if I can get m elements with those bits set? And if not, what is the minimum additions I need to do to make that possible? And if those additions are not enough, then try next higher bit. You do not look for the highest bit directly that appears in an element. Instead, you try to force a bit to be present, even if it currently very present. So here is the current value of so you start with notified bits, because it's the current point. Now you look at bits from high to low. Okay. For a given bit, you tentatively require in the final line, if this means every chosen element must ask simple question. If I require this bit together with the bits already kept, now still make at least an elements of k-points. Hence this for each number, compute how many increments it would take to reach some number greater than itself that has all the required set bit set. And you're not trying to make them equal. You are not inserting value. So let's say I'm trying to, I have my array elements. For this bit, for each of the numbers, I'll calculate how much is required to have this bit set. Then consider the smallest m elements, and if that sum is less than k, we go back, then they are the set. But then when I move to bit 29, how do I consider them? Because now we don't have bigger information, right? So answer, you don't have to person, right? And just want to carry it forward. When you accept a bit 30, you're just not saying bit 30 is a every chosen element must have must have bit 30 is a. That requirement does not disappear in your program. So when you move to bit 30 and you now have stronger requirement, the chosen element must have. But I was thinking more in the direction that let's say I select the least m elements, right? That has lowest sum less than one here that have the bit set. Then um, how do I carry this information about the additions I have already done to make the bit set possible? Like obviously we would have used operations of first one and these elements also same, right? How do I consider that going ahead? Why does it say this bullshit? I don't need this. You're thinking in terms of actually performing the operations step by step and using up operations. This is not how the algorithm. The algorithm never comes to real operations until the very end. When you check bit 30 say you're actually incrementing any numbers. You are only answering a hypothetical question. If I eventually want bit 30 to be present in the end, what is the minimum total cost? Oh, so it's like for each bit, we calculate the minimum total cost and then just see for how many they are possible. For each bit, you're not modifying the array, you're not planning operation, you're only estimating the minimum total cost needed if that bit was required. Keep a running set of required bits for each new bit you try to add. You calculate from the original numbers the minimum cost for each number to add all the required bits. Take the cheapest and cost. And also, so do actually the calculation with all bits individually, like for bit 30, I do the calculation, and for bit 29, I do the set product value without any consideration of the term. Almost the days are on right? You do not treat it as a day, you treat them incrementally. When you check for the 30, you allow the consumer 30 must be right, and then the 30 already keep it. And you want to do that, do not forget about it. You calculate the consumer with 30 and with 29 must be right. If 30 is not available, then you know, you need to move to 29. You know. So it's like for each increment, we do with 30 is set, then with 30 and 29 is set, and so on, till with 0. All right. So how do I actually find out how many operations do we need? Uh, well, finding the operations is not that hard. Uh, for 30th bit, I just need to consider to make the element if it does not have a bit set of each 1 to the power 30, 1 to the power 29. So it's just 1 to the power 29 minus element operations element for 30th 129 bit set because I need to consider 1 to the power 30 should be present, 1 to the power 29 should be present, something, you know, well, how big is that? Yeah, so, uh, but this breaks for case like 8 required the certain bit. Um, in this case, 8 is greater than the bit, but we still need to set that. So we just check from header level, start with the original number. Mm. For each bit in the required bits. So the bit is already one in the number denominator and the letter zero. Got it. That's how they want us to do it. I want to have dinner. Not a good problem. So our entire idea is fucked. Nah, sometimes ideas should run virtual language. How much time is that? Definitely not 105. I'll just bring my dinner then I'll just continue. I think my phone was fine. Yay! It's a lot of dinner. No, how the fuck do I keep it? Just want to keep my keyboard up, please. Can I keep it? Thank you very much. Hmm. Well, as you can see, we're getting nowhere with this problem, so I'm just going to end this video. And I'll have my dinner. See you guys. I'll probably upload it, but yeah, whatever. If I don't wanna